All right, so guidelines for solving a mixture problem. So step one, you're going to set up a picture using what I call jars. Step two, put the percent of salt or acid or whatever you're talking about aside or inside the jar. Put the amount below the jars, so in liters, milliliters, whatever. And then combine these numbers into an equation. So it seems kind of confusing the way I just explained it. I think it'll make more sense once you see the picture. All right, so it says Jeff wins $20,000 in the lottery and decides to invest it into 2 certificates of deposit. That's called a CD. I have a friend that worked at a bank and didn't know it was called a CD. So every time they called her, she said, they called and said something like, "Do you sell CDs there?" And she'd say, "No, this isn't a music store." Like, hang up on them. They're like, "No, it's a certificate of deposit." All right, so one pays 7% and the other pays 3.5%. If Jeff's total interest is $1,225, how much money is invested at each rate? Okay, so he's taking $20,000. We don't know if he's doing $10,000 in each one. We're not really sure. So I'm going to draw these little buckets, so these jars. On a lot of these, you'll have a third bucket over here, but like we'll have another thing that says a percent on the end, but we're not on this one. Okay, so the first one pays 7%, so I'm going to put 0.07 inside the jar. The next one pays 3.5%, so that's 0.035. Below the jars, we're going to put the amount of money that we invested at those rates. So I don't know how much he put into the 7%, so I'm going to let that be x. So let x equal amount at 7%. It doesn't matter what you set x to be, it could be either one. So let's say that was $8,000. How much would he invest at the other one then?
$20,000 minus x.
Yeah, so if that was 8,000, you'd have 12,000 here. So we're going to put 20,000 minus x.
If x is the amount at, wait, but that's 1/5. 0.035 is 1/5 of 0.07. So shouldn't it be like?
It's not 1/5. It's half of.
Oh yes, that's what I mean. I'm sorry.
Yeah. Okay, so you're thinking about it logically. I see. All right, so this is the amount of interest he's getting on just this first bucket. It'd be whatever he invested times 0.07. This is going to be the amount of interest he got from the second bucket. So whatever he invested times 0.035. The total amount of interest he got was $1,225. So that's our equation. We say, okay, he had a certain amount at 0.07. He had a certain amount at 0.035. And that equals 1,225. So you're just multiplying the amount times the percent. Amount times percent. Okay, solve it out. So I get 0.07x plus, what's 0.035 times 20,000? 700 minus 0.035x equals 1225. Okay, notice when I do 0.07 minus 0.035, what do you get? 0.035. Okay, so my 0.07 didn't disappear. Everybody always asks me that. I combined those two here. So I did 0.07 minus 0.035, and I got 0.035. Okay, so then I have plus 700 equals 1225. Okay, so I'm going to do 1225. I'm going to subtract out the 700. 525. So then I'm going to divide 525 by 0.035. Okay, so x is 15,000. So he put $15,000 in the 7%. Notice I asked how much is in each rate. So you could have let x be either one. I don't know what your x is. So in your problems at the very end, you need to say what your answer is for both of them. So you're going to say 15,000 at 7%. And then how much was that? 3.5? 5,000, right? The rest of the 20,000. So make sure you're stating that. Jeff's my brother, by the way. So he's an investor. Occasionally I'll have family members pop up in these. Okay, so let's try the next one. So it says a bottle contains 750 milliliters of fruit punch with a concentration of 50% pure fruit juice. Elizabeth drinks 100 milliliters, and then she refills the bottle with an equal amount of a cheaper brand of punch. I don't know why. If the concentration of the juice in the bottle is now reduced to 48%, what was the concentration of the punch that Elizabeth added? Okay, so we're going to set up our jars. And in this case, I'm going to have 3 jars. I'm going to say I had a percent for the first one, a percent of fruit juice for the second, and I'm getting this new percent for the third. So the first one was 50%, so 0.50. We don't know what the concentration of punch that she added was, so I'm going to call that x. So let x equal percentage of cheaper juice. So percent of the cheaper juice. Okay, you end up with a 48%. So that's the concentration of the result. Okay, so I have my percentages filled in. Okay, when she added the juice, this is kind of a tricky question. The first class had trouble with this. When she added the juice, the cheaper juice, how many milliliters were in the 50% juice? Yeah, did you guys see that? It's not 750. The other class kept telling me it was 750. Did you guys see that? Because she drank 100 milliliters. So that's gone. We don't have that 100 milliliters anymore. So if she's refilling the bottle, how much of the cheaper juice did I add? 100 milliliters. I end up with a total amount of 750 milliliters. So see how these add up to be like 650 plus 100 is 750. The same thing for most of these problems. It's going to be like that. The only reason we didn't on this one is because I didn't tell you that he had a percent, like he made a percent up here. Like I just told you the total interest. Okay. So we need to set up the equation. So I'm going to say 0.50 of 650 plus x times 100 equals 0.48 times 750. So a lot of people get really confused about why we're doing this. We're basically talking about how many milliliters of pure fruit juice I have. So if I had a concentration of 50% pure fruit juice and I had 650 milliliters, that means I have 50% of that. That's pure. The rest of it's like water. So you have 50% of that. Okay, so solve it out. So I have 650 times 0.5. Plus x times 100, so 100x, equals 0.48 times 750, so 360. Do 360 minus 325. Divide by 100, so I get 0.35. Okay, that was your concentration of the cheaper juice. It should make sense. We had 50%. We added something less concentrated to get 48%. So it should make sense in the end. Notice the percentages don't always add up. I mean, they're not adding up to be 48. You up? Yeah, it doesn't necessarily add up because you have different amounts of those things. Okay. All right, next up. Oh, Miss Summit just left. Okay, Miss Summit has 2 brine solutions, one containing 5% salt and another containing 20% salt. How many milliliters should she add, or should she mix to obtain 1 liter of a solution that contains 14% salt? Okay, so inside the buckets is your percent salt. So in the last one, it was the percent pure fruit juice. So inside the bucket, I have 5% salt, so 0.05, not 0.5. 20% salt, I'm getting a mixture that's 14%. So those are my numbers inside. Okay, what are my amounts? It's tricky. Underneath the last one, underneath the 14%, I put 1. Yep. Okay, so one of these has to be x. It doesn't matter which one. So let's say let x equal the amount of 5% salt. So this one's going to be x. So what goes underneath the 20% salt? Yeah, exactly. Did you guys see that? Melanie's good at these.
What did she say?
1 minus x. Because if this was 0.3, this would be 0.7, right? They have to add to be 1. So it's 1 minus x. Mm-hmm.
Why wouldn't you, like, since it runs in milliliters at the end, why can't you just do 100 milliliters?
1,000 milliliters, yes. You could. Do you see what she's saying? You could do 1,000 milliliters here. Did it say they want it in milliliters? Yeah, how many milliliters? So do you guys want to do it that way? Doesn't matter. So this can be 1,000 here. Those of you in chemistry probably knew that one. And this can be 1,000 here. Or you could just find it in liters, and then you can convert it at the end, so it doesn't matter. So I'll write myself a note. So 1,000 milliliters equals 1 liter. Okay, so now set up your equation. So I have 0.05x plus 0.2 times 1,000 minus x equals 0.14 times 1,000. So I get 0.05x plus 200 minus 0.2x equals 140. Okay, so keep solving. If I subtract my 200 to the other side, I get negative 60. I do 0.05 minus 0.2. I get negative 0.15. So I'm going to do 60 divided by negative 0.15. So I get x equals 400. So you have 400 milliliters of the 5%. And the rest has to be the 600 milliliters of the 20%. Make sense? Okay, last one we'll set up, but I won't finish it out. Okay, so it says, the radiator in a car is filled with 60% antifreeze and 40% water. It's recommended to have the concentration of antifreeze in the summer to be 50%. If the capacity of the radiator is 3.6 liters, how much antifreeze needs to be drained and replaced with water to reduce the concentration? This is a hard one. Okay, so your radiator starts out, it's 60% antifreeze. So notice inside the bucket, I'm saying percent antifreeze. You could do this problem with percent water, and it would still work out. So you could do it the other way. You just need to pick what percent you're talking about. Okay, so I have 60% antifreeze. It's at 3.6 liters. Okay, I'm going to drain some stuff out, and then I'm going to replace it with water. Well, maybe I shouldn't do 3.6 down here. Let me think about it. So I'm going to replace with water. So I'm going to add in water. So what percent antifreeze is water? 0, right? So you should have 0 here because that's water. I hope there's no antifreeze in your water. When you add those together, you're going to get 50% antifreeze. That's what you want for the summer. Okay, that's going to be 3.6. The total is 3.6. So this first mixture is what I've now drained some of that out of there. So it's not as full as it should be. It's not 3.6. We're talking about how much water we're adding, right? The question was how much water should be added. So what's this amount underneath? Someone besides Melanie's. Melanie's got all these. Someone besides Elizabeth, too. She's got them, too. Anthony?
3.6 minus x.
Yeah, do you guys all see that? 3.6 minus x? Because these add to be the 3.6. Okay, that's your equation. So what happens is the second part doesn't, like it's 0. Doesn't matter. So I have 0.6 times 3.6 minus x equals 0.5 times 3.6. And you can solve it out. Okay, and the last stuff I want to talk about is the job sharing, and I'll let you guys start on your homework. So it says guidelines for solving a job sharing problem. Step 1, find the fraction of the job that can be completed by each person in 1 hour, a minute, or a day, so whatever time period you're talking about. Step 2, add the fractions for each person and set them equal to the fraction of the job that can be completed by all of them. Your equation should look like 1 over x plus 1 over y equals 1 over z. We've done these before. Do you guys remember these? So it says Mitch and Caitlin share a paper route. It takes Mitch 70 minutes to deliver all the papers, and it takes Caitlin 80 minutes. How long does it take the two of them when they work together? Okay, so remember when we did these before, we always said the amount or the percent or the fraction of the job, amount of job done in 1 minute. So in 1 minute, Mitch can do what fraction of the job? 1/70th. In 1 minute, how much can Caitlin do? 1/80th. Right, because it takes her 80 total minutes. Okay, we're going to let x equal amount of time together.
Less u.
So the amount of time it would take working together. So in 1 minute together, what can they do? Do you guys see it? 1 over x. So if it takes them 30 minutes together, they'd get 1/30th of the job done in a minute. So set up your equation dealing with 1 minute. So in 1 minute, Mitch does 1 over 70 of the job. Caitlin does 1 over 80 of the job. Together, so Mitch plus Caitlin, 1 over x of the job. Solve it out. Okay, we like to multiply through by the LCD. Yeah, so we're going to multiply through by all of them. You could actually find a lower common denominator than that, but we'll multiply by all of them. What did you say? Yeah, you could do 560x, yeah.
Yes.
Okay, so we're multiplying through by everything in our equation. Okay, so in the first fraction, I have 1 over 70 times all of that, so the 70s will cancel out. Now don't draw lines through them, because then that's going to mess up the other ones. So you're just thinking in your head, okay, 70's gone, 70's gone. So I'm left with 80x times 1, so 80x. On the next one, the 80s are gone, 80s are gone. So I have 70 times x times 1, so 70x. Equals, now the x's are gone, 70 times 80, so 5,600. Add them together, I get 150x equals 5,600. So do 5,600 divided by 150. So 37.3, is that what you guys are saying? So together it takes them a little bit more than 37 minutes. So about 37 minutes. Okay, like I said, when I've taught this in the past, people will always be like, oh, together it takes them 180 minutes. No, it shouldn't take them longer working together, right? It should take them less time than it takes for each of them. So your answer should be less. That's why we do 1 over, 1 over, 1 over, because it's smaller. Okay, let's try another one. So Ann and Dalton are painting a house. Working together, they can finish painting 2/3 of the time. Oh, working together, they can finish painting 2/3 of the time it takes Ann alone. Dalton takes 6 hours working alone. How long does it take Ann to finish the painting the house alone? Question mark. All right. So if it takes Ann, we're going to let Ann, so let's call that A. So let A equal amount of time for Ann alone. So then how do I write the amount of time it takes for them together. So that'd be 2/3 of the amount of time it takes for Anne. And then Dalton just takes 6 hours, right? So that's the total amount of time it takes for them. So in 1 hour, think about the fraction of the job each can do. So in 1 hour, Anne can do 1/A, Dalton can do 1/6. So together it makes 1/2/3 A. I'm writing, it's not writing. So do 1 divided by 2/3 A.
1.5.
Still writing, still not writing. It's going to be a big blob when it finally comes. Okay, so you need to multiply through. You could do 1 divided by 2/3 A if that's too messy for you. You could write what instead?
1 times
3/2A, right? Does that make sense? The A is still on the bottom. 3/2A. I think it's had it. Still writing. Oh, there we go. Okay, so 1/2/3 A. So what I was just saying is 1 divided by 2/3A. The A is on top of the 2, right? So it's 1 times 3/2A. So it's 3/2A. So you could rewrite that part if you want. So I get 1/A plus 1/6 equals 3/2A. So this one's pretty easy to get at least common denominator. So what's LCD going to be? Yeah, let's just make it 6A. So when I multiply 6A into everything, 6A times 1/A is just 6. 6A times 1/6, the 6's cancel, so I get A. 6A times 3/2A, the 6A and the 2A reduce to 3, so I get 9. So A equals 3. So it takes Anne 3 hours working alone. Oh, she's speedy. Dalton, you're slacking. It takes you 6 hours. All right. So we'll stop it there so you guys can work on your homework. It's a lot for today.